of exploiting our biggest resource we have left, and that is resourcefulness. All right, you see that shift? You go from exploiting resources to exploiting resourcefulness. We'll let that sink in for a minute. All right, we've got a clear directive. Engineers need a requirement. And thank you, Paris, COP21. I now have one I can write down in a couple of words. That's where we started, that's where we're going to get back to. Reduce greenhouse gases by 80%. Why not use that? I've been reading this book. I wanted to put it up here because I'm almost done with it. I got to say, I'm not all the way to the end. I have not yet seen the word ROI or even the concept of it. So this is our limits to growth people here. This is probably a popular book. And here's a quote. The main challenge in our global future is not to solve the problems we are facing, but the agreement to do so. And that's probably the best statement I've seen from the book so far. Really, it's about what our minds are doing at this point. Here's the prediction that's given in that book: a doubling of the amount of energy used by 2052. Big increase in CO2 emissions, and this is the limits to growth people. These are those models. So maybe they are missing EROI. Does EROI actually inform a long-term view? If it was in there, if Jürgen Randers knew about it, would his predictions be different? Because his prediction is not that uncommon. This switching over to renewables. That's clearly what's got to happen, right? We're going to go to 100% renewables. We need this climate action, and I think everybody's heard this 100% renewables thing, right? It's really catching fire with imagination and with intent, and with intention and vision. There's a lot of people who share that vision. Would EROI inform that vision for them a little bit? Would it inform them that substitution for fossil fuels maybe actually isn't going to happen regardless of your intent? That'd be interesting. But we know we must take action, right? No question there. I think we might actually have agreement in all the room. We must take action. Problem, who's we? What would actually compel that action? What would the action be? And when would we do the action? This simple statement. Hard realization. All right, so since that's hard, and we all agree that if something's difficult, we sort of just go away from it for a minute. So we're going to do that. We're just going to talk about the Titanic. So you all know about this boat, right? There was this boat, and at the time the boat was built, it was the state-of-the-art design. It was designed to be unsinkable. Actually, it was. It was designed to be unsinkable. So when it went into its final port before it loaded up with people, they only put 1/3 of the lifeboats that they would have actually needed on it because it was unsinkable. So maybe that was a mistake because it did sink. But they didn't know that because they weren't going to sink it. So off they went, and they were going to make the most luxurious, fastest, biggest ship that was ever made, and they did it. And they set off, and it was full of people. And the owners had advertised a fastest trip ever, most luxurious, fastest trip ever to New York. And the ship was unsinkable, and you had a good captain, and off they went. No problem, right? Until a couple days into the journey, 14 different radio communications to the wireless operator. There's big icebergs in the way. And I'm sure that person relayed that information. The person had accurate information, and they relayed it. And I'm sure they were going, I'm telling you some information I think you need to know, right? I'm pointing at the climate guy here. I'm telling you what you need to know. And that ship hit that iceberg at full steam in directly the lane that they intended to be in. Okay? Is this a little story for us? Is it? I think it is, because I want to do it like this. I want to ask, was that ship actually doomed? If we back up a little bit, can we find the point where one decision by anybody in that whole story would have changed the story? 1,503 people died on that ship, including the designer of the unsinkable ship. What would it have taken to not hit that iceberg?
Did the designer say that it's unsinkable?
Yes, it was designed that way. It had lots of special features that made it unsinkable. And there's one more little fun fact here. That captain had hit icebergs before. He wasn't worried. You know, you can hit icebergs. And I'm in an unsinkable ship. Yeah, so, right. So what did they have to do? They had to actually not hit the iceberg, right? That's kind of, we don't need a lot of science to figure that out. That ship with all those people would have made it to New York if they hadn't hit the iceberg. So let's think through it a little bit. And you get what the iceberg is in my little story, right? Okay. So if they had even slowed down a little bit, they only had 2 minutes from when the person up in the top spotted the iceberg, because it was at night, right? They spotted the iceberg. They tried. They threw the propellers into reverse. They tried to change course as fast as they could, and they slammed right into the iceberg. 2 minutes. That's not too good. So they weren't looking ahead very well. It was night. They were going full steam right into the iceberg. So yeah, we don't want to do that. They would have had to have slowed down. If they'd have been more cautious, probably could have missed that iceberg. All right, so we're going to do a retrovision here. We're going to say, okay, the telegraph operator, scientist, right? I see something you all should see, and I really want to communicate to that effectively. I want you to understand what I'm talking about, right? There's these other ships, and they're saying there's really big icebergs right in the way. Okay. So what would you do to be more effective? You'd go straight to the top, the captain, right? Captain, the navigators, somebody, listen to me, I'm telling you. And the navigators are like, oh, well, we could go south a little bit, but the boss says no. Okay, let's go all the way to the captain. I'm in an unsinkable ship. I got first-class customers here, and they paid for the fastest journey to New York ever. And so go talk to them. Say, look, your investment is at risk here. We paid for an unsinkable ship. What are you talking about? And then the first-class passengers, hey, I paid for first-class passage. Nobody's doing anything yet, as far as I can tell. How about the economy class passengers? If we got them all upset, then maybe they would make noise, and then the captain would have to say, oh, okay, we'll slow down a little. But I don't see that happening either, because they're third-class passengers and they're the workers on the boat, and it's not their place to do that. Or if they got upset, they'd probably be thrown in the brig, right? You don't get to make noise. And then you've got the engine room, because there is one thing that would have allowed that boat to not hit that iceberg, and that's if the engineers had stopped putting so much fuel in. The boat would have slowed down, and they might have missed the iceberg. Okay, that's weird. Who saw that coming? I don't know. You got to leave the coal and oil in the ground. There's a really simple solution. Yeah. And remember that isn't a target. An aside. It's not a target. Don't run into it. All right. So, can the engineers save the ship? I mean, has your brain absorbed that yet? That idea? Because think about it. What if they did? What if they slowed down how much coal they were putting into the engine? When they got to New York, they'd have been in trouble. But they'd have got to New York. And 1,500 other people. No wonder we're in such a hard place. No wonder we do goofy things that people want us to do, because that feels better than doing what everybody would get mad at us for doing. Right? Right, but unfortunately, that looks a bit like this, Let's keep doing an even worse job of hitting this thing. Oh, dear me. Because that's what EROI tells me, actually. So what I'm going to do, done with our Titanic story now. I want to switch now to thinking about the future scenarios. That's why we're here. And if I think about a future scenario, what I do is I actually go there. Push the insanity button, go into the future. So I'm in the future, and I am picturing a scenario where the engineers save the ship, and I want to know what that looks like. So 100 years from now, we look back, and we see that. Something changed. There was a change of course. We can definitely see the path that we were on, and we can draw that line, and we can go, kind of glad we didn't do that. And then we can go, wow, what happened back then? Right about the turn of the 20th century, or 21st century, something happened. What was it? Well, there was this energy transition. There was a sunset of the fossil fuel industry, and it began right about that time. It wasn't a sunset like that fossil fuels went away, because they're like the most important fuel we use at all, but we use a teeny amount compared to them, and we use it really wisely. That's kind of interesting, because this 80% reduction by 2052 looks like that. That's numbers there. It probably isn't a smooth path, but it's about 4% a year. 4%. Maybe it wrecks economies, maybe it doesn't, I don't know. But that's what it is, that's what it looks like. But here's the trick. Here's why I do transition engineering, because that is not what it looks like. I cannot engineer for you, nobody can 4% reduction a year. That doesn't make any sense. That's not how you do projects. This is how you do that. A lot of people are using fuel in a lot of different ways, and every single one of them individually in their own way has to make a whole shift in what they do. Step changes. Projects. Reduction isn't a project. It might be an outcome, but it's not a project. A project is moving to a new way of doing things. All right? So what this is the sum of these. But that's the way we got to think about things. That transition happens one project at a time. Thus, we are doing the work of heretics. Leave yon fossil fuel in the ground, for it shall surely be required for more worthy tasks later. And thou doth risk much in the taking. I just love the medieval thing, by the way. All right. So here's how you do it, because it's a hard job tapping into resourcefulness instead of resources. You know, last century, we built up a lot of capability, and we thought we were very clever. Actually, we were just at a really big buffet eating a lot. You know, we didn't have to be that clever. We had to figure things out, but we didn't have to be that clever. Now, we have to tap into every bit of creative problem solving we have got. So, how are we going to do that? Well, first we got to learn our history. So we've got a 7-step method that transition engineering is working from. First, we have to learn our history. Does that make sense? Actually, if you don't, you end up getting stuck in nonsense world, where we're doing the solar and all that. You really do have to learn your history. So that's not hard. Then,
Sheet project doesn't take an S.
there's just one?
Yeah.
Oh no, we're doing lots of them. Lots and lots and lots of them. And actually, in my development of this, I called it target projects, but I love this shift so much. That's what it is. I'm borrowing your name. We're working together now, in case you didn't know. All right, so you learn your history, but most importantly, you learn about the dynamics of your history, not just we did this, then we did this, and here's a graph. Why, in 1950, did every graph we ever plot go, what the heck happened? Because we need to know that. And then we got to study today, and that you know what I'm talking about, because you all do that. But here's heresy number 1, okay? You ready for it? The prime heresy is that's wrong. Energy resources flow in, and they get converted, and then they get changed into something you can sell, and then you use them. That's last century's model. It's not wrong, it's the wrong model. It's an open flow model, and the world is a feedback control system. So this is a feedback control system model of anthropogenic system dynamics. I'm not even going to talk about this, because that would be another hour. But here's your physical system over here. Humans interact with it. Economics is a little actuator within that system. It's not the whole system. That's why mostly you don't see it in the right way. But anyway, what this all tells me, feedback control theory applied to human systems, is the 3 laws of anthropogenic dynamics. That's what you have to know. If a system works, there will be great resistance to changing it. That's how we survive. That's how our little hairless, toothless species is here 60,000 years after the fact. Because when we get something right, we have whole ways of never changing it. Culture, tradition, education, our way, our religions. When it works, you don't change it. That's rule number one. If a system does not work, it causes a crisis, which stimulates those few people within our population who are creative and observant and resourceful and willing to try things. It pops them into action and they change. They cause a change. They cause a change because we have our other adaptive capacity, which is when the system changes in a way that works, everybody follows real quick. We're really fast adapters, fast learners. You know, a lot of us came from other places and we learned how to get from here to our bunk rooms first time. The first time, we're not quite sure, done. We're fast learners and we hang on to what works. So that's, if you don't believe me, there's DOS and Windows. This industry knows these rules. Okay, that's why they keep doing it to you. You hang on to what you know and then they make you change and then, okay, changed, I can't even remember what I was doing before. Okay, there's some young faces that are confused. This is what happened before a long time ago. Okay. Onward. We now have to talk about the future. And guess what? We as a society have a mantra about that. You can't know the future. And now I got to go do that. I got to violate that social mantra that you can't know the future. Well, okay, guess what? You actually can. Because we can project with the simple mathematics what would happen if. That's the question of the future. What would happen if we kept doing that? And what we're looking for here in transition engineering is to understand the unsustainabilities in the future, because that's not where we're going. I'm not going to invest anything in anything that can't exist, because that would be dumb. So that's heresy number 2. And we actually have a tool that we use to do that. And it's called the flying elephant tool. It's great to have an idea. Never, never stop having ideas. And it's really good to understand what your needs are. Who needs what actually needs? What are your needs? And it's great to try and think of ways to take a potential idea to a potential value proposition. But you have to know that there are barriers you have to get over. And each barrier is going to take some R&D. We know that. So the idea that, well, it might be 5 more years before we get this to work, that's okay. We're willing to go there with you. But if you can't march through the fundamental basis of that and see that it's actually going to work, then we aren't going to do it. So there's a lot of things in this category that I've worked through this and done studies for companies. Look, you don't need to invest in hydrogen infrastructure, okay? It's not going to happen. Lots of good reasons why. And the ROI is the easiest way to see what's not going to happen. I don't have to spend very much time in this. I can just go, nope. All right. So we're moving on now. We've got to do what we call the forward operating environment. What do we actually know about what will happen in the future? That one, thank you, Paris. We now have got a quick answer to that. I just need to put a peg in the ground. We are not going to get to 1.5 degrees, and the world is finite. So, got to the next one. Now, here is where it gets fun. We've got to go do this project, this path break system concept generation, where we've got to move ourselves into an impossible situation. We got a few engineers in here. Any of you have patents? You cannot innovate if you're working on something there's already a solution to. You have to be working on something there is no solution to. So, in order to put ourselves into a place where our minds will tap into that resource of resourcefulness that we have, the trick is to move ourselves 100 years into the future mentally. 100 years in the future, I do know what's going on. This is going on. People are going to a place that they call their home and they're sleeping there at night. Because that's what we do. We are large, vulnerable primates. And we need a nest with others of our kind to be safe while we're vulnerable. A place where we can take care of the little ones, take care of the old ones. That is what we have always done and what we will always do. That's a fundamental need. We need to work with others in our community on all the other things that we do. That is us. However we do that, there's been how many tens of thousands of ways that humans have come up with to do exactly that same thing? The exact details of it isn't important. What's important is that we're doing these essential activities, people like us, with 80% less total energy. What does that look like? How do they do that? And it's us It's here in this place. A lot of these buildings will still be here in 100 years. And that is the most fun thing. And I love doing this with students. They come up with great stuff. All right, that moves us on to once we've seen the future. It's a fun project. Then you've got to come back, compare that to things you've learned about the past, compare that to where you are now. And now it's time to actually come up with a project. You have to do something. You have to do a project. And that's transition engineering. It's projects, not ideas, not philosophies, not advice. It's projects. You've got to do something. All right, so to do that, you've got to set your system boundary. What's the essential activity we're talking about? We defined system boundaries around essential activities. Not the energy you think you need, essential activities. And then how will you do that? What's the problem? Well, that need is now going to be met without fossil fuel. And we put ourselves that challenge first. That challenge first. If you can do that without fossil fuel, then you've made that whole transition step in one go and you've saved a lot of money. And you're going to be miles ahead of the competition. All right, what are the requirements? The same as they've always been. This here, safety, security, sustainability, that's called survival. You either survive or you don't, all right? And you have to be able to do it. All right. So here's that bit of heresy I was talking about. This methodology, you've got to use extreme creativity, heretical innovation, and the brainstorming process. And I'm going to give you a quick example of a project that was done at Grenoble IMP at the ENSA Cubed institution with a bunch of students. We went through this process. Guess what students think is an important, essential activity?
Drinking.
Oh, they actually said food, okay. It was French students, I told you that, right, in Grenoble? No. Kiwis, it would have been drinking. Right, food. They want to eat at midday. How can they possibly do their studies without that? So to them, that came up as a main thing. And they were very focused on this COP21 transition. That was a major thing to work on. So this is their little cafe. It's called Are You Green? A little example of their nice new swanky digs that they've got there. Brand new green building. First thing, go back 100 years in history. Think to yourself, were there students at universities 100 years ago? Oui. No question. So that's okay. This is an essential thing that people do. Would they have eaten a midday meal? Turns out, yes. And what were they eating? Well, good food. And probably mostly local foods. I mean, I don't know. This history project is yet to really be fleshed out, but just off the top of our heads, what little we know, it looks like probably that system existed 100 years ago. And it did it without fossil fuel. Interesting. All right, so then until today, what happened? Oh, we found there's very little trains at that time. Very, very few trains. So whatever they were doing, huh? It was just coming in. It was this beginning of the boom of the trains. Right. Oh, but Grenoble had trams that ran all the way up the valleys and down and up to the paper mills and out to the farms. And so, yeah, all right. So historical development, we've had the changes you probably can all imagine in that time, and things have really changed from a simple bowl of what you might call pottage, which is what you have goes into a pot, and then there's some bread and some cheese, to what you open the door of a big refrigerator and pull out in a package. So that's a pretty big shift in the same essential activity. Historical growth trends. This is the number of students in French universities. You can look at that as a linear progression or as a exponential function. If it's linear, it's 40,000 students a year are added, and if it's exponential, it's a 5.2 growth rate. Flat trend in trucks. I thought that was interesting. It seems like there's a lot of trucks. There are a lot of trucks, but the big boom in trucks is over, apparently. It's been pretty flat. Oh, yeah, this is number of trucks, so bigger trucks. So that's how the food is moving in general. So now we sort of know, gathering data about how many students are there, how much do they eat, what do they spend. You got to do an audit. You got to do an energy audit. Where is the carbon? Where is the fossil fuel in our food system here? You can see some of it there. And they also wanted to include the waste stream. What happens with the waste? So today, we know that different kinds of transportation have really different footprints, and we know that our food is coming from different places. We don't know yet. They actually have to sit down. This project was done last November, not the project, the brainstorm. The project is going to be done in a few months by a group during what they call their Creativity Week. So there's going to be a couple of groups actually doing the project, okay? And you'll see what the final project is in a second. But there's kind of, this is one of those linchpin things. It's really only 11% of the food chain that is transport, but without that, you don't have the connection between the food and the place you're at. So while it's not the biggest use of energy or the biggest source of carbon in our food chain, it is the linchpin source of food in our food chain. So look into that some more and find out, okay, well, if 80-some% of the carbon is from the food itself, that's where it is. What they're really going to have to do is look into the supply chain. What is that food about? What's the menu? And this is interesting because now our transition engineering project turns out to be mostly about the menu. Our business as usual scenarios say, look at this, by 2052, if previous population growth trends continue, we could need 7 more of these institutes. There could be a heck of a lot more students here. Or if it's linear, we'd only need 2 more. Is that what's going to happen? So they're going to have to sit down and try and think about where are we at there in that growth curve. Are we at a peak? And so that's going to be interesting. If we do continue business as usual, then can we substitute the truck fuel that we do use with electricity? And that looks like probably a not. If it's flat, we still have a big truck demand. And the forward operating environment here, we've got a really big change. So what does that change look like? Well, a bunch of the students got together and had brainstorms about that. So they've been through this whole process, and here's their ideas. In a brainstorm, you don't limit yourself to anything. You throw everything out into the brainstorm that you can think of. And so here's things they came up with. Local food sources, seasonal food sources, a biodigester that uses the waste and then that biogas could fuel the trucks. Vertical and rooftop farming. We could put farm on the top of our building and we could grow things on the sides and we could we could look at our supply chain for the food and only accept things that came by electric train or by ship on the river or something. We could look at the menu and get a low carbon menu because we saw how important that is. Low greenhouse gas menu. We could get bikes with trailers and bicycle to get the food instead of having delivery trucks. Solar cooking. We could build a solar cooker. We could build a big barbecue. All right. We could probably, with the menu, reduce from the 5 giant refrigerators to 20%. Much smaller, and we could eliminate packaged food. So these were their ideas. That's a lot of ideas. Which one is right? Yeah, that's not how we do brainstorming. Brainstorming, we try to put all of them together and look at them the way that they intersect and how they multiply with each other. So this is a process we call strategic analysis. It just uses concept evaluation, which means you take things that are sort of infrastructure concepts and things that are behavior or technology concepts and you put them crosswise to each other and you calculate how close you can come to meeting your goal in each one of those intersections. And what this does is it defines for you an opportunity space, which tells you the types of things you want to try to do, but you got to do more than a few of them. And the first step is each one of those intersections, you want to do technical feasibility first because you don't want to waste any time. If it doesn't meet the flying elephant requirement, then we don't have to work on it anymore. And then does it meet our target? Calculate how much fossil fuel that would reduce and does it reach 20 out of today's 100? Availability for implementation. So you rate that on yes, it's available right now, maybe by 2050 or probably not. So just a possibility. And then we've got things we give scores to, so rankings. And those scores are then combined to be green for good and red for bad. So let me show you. We've got really the biogas plant, if you sit down and do some back of the envelope calculation, you see your production of waste, and it's not going to run trucks, right? So that one just sort of isn't feasible. And the edible landscaping, if you actually take a good look at this idea of growing your food on your building, while the students loved it to death, you could grow a few herbs, but you couldn't feed your student body with that. So that one's kind of off the table. And renewable energy for freight, yeah, that one's a little bit trickier too. And so these are the roughly calculated numbers for you know, how much reducing your refrigeration and using seasonal food you could reduce from 100 to 97. But the big one, look at that. If you change the menu, and remember, the color is, well, could it be done? And the color is all those other factors wrapped together. Where do you see the green with the yes, with the lowest numbers? Those are opportunities. That's what our project is now going to be built around, what they're actually going to do. Okay? So hopefully you understand this little exercise. If you go through it once, you're like, oh, okay, that's easy. I see what you're doing. All right, so yellow is okay, red is, that's on the higher end of not so good, and green is really good. Could be done right now. Man, it looks like it's in how we structure our end use is what's actually really important here. That affects everything else upstream. It affects my ability to do any of the other things. We see a lot of possibility in, you know, where these things intersect. So the shift project idea, they're going to do the work of auditing the energy use, auditing the menu, talking to the people who do the food service, and they're going to try and do one day where the food is fossil free. And they're going to learn. I don't know if you noticed, I didn't point it out, but in the shift project, you have to learn. You have to learn because you're going in a new territory. And you can't change the whole direction of how you think and what you're working on if you don't learn from every little thing you do. So they're going to learn about the foods that the supply chain that is there at their little cafe. They're going to learn where the local food is and what it is. They're going to learn about menus and how you put together menus for a group of students. And how would you serve those students and minimize things like how much refrigerated food you need and that sort of thing. And they're going to build a solar cooker. And so on this day, they also want to keep track of the economics. Like if we're going to get our stuff from the suppliers by bicycle, and we're going to haul the waste back out to the farm by bicycle, then we're going to have to pay somebody for that labor. And so we're going to have to keep account of what it costs to do this and reflect that in the price of the food on that day so people can understand. And they're going to keep track of how many, like, did we cost people their jobs by doing this, or did we create jobs by doing this? You see, there's an awful lot of learning going on here. An awful lot of learning about what's around them, how the system works, and how much impact different kinds of decisions like your choice of menu have on the whole ability of that system to shift to a non-carbon state. All right, so here's the finale, and that is that the project of tapping into resourcefulness is about redefining the whole solution space. Removing, regenerating, redeveloping, retrofitting, redesigning, replanting, reclaiming, reorganizing, reforming, recycling, reimagining the whole future. And that, I reckon, is going to be done by Generation Re, because we have left it to them. We should dedicate ourselves to helping them do that, but we have left it to them, and now they got to do it. My own what am I going to do is, since this method works, since I know there's resourcefulness out there as a huge new resource to tap into, along with a group of other people, I've founded the Global Association for Transition Engineers, and these are our statements of who we are and what we do. And the very first one is, we will be honest. No more flying elephants. We know we can get money that way, but that's not what we're about. We're going to show you the value in the other direction. We're going to show you the value in that by just doing it. And yeah, we might have to do it with students for a while because that's who's free labor. Or actually, they're paying to do it. Never mind. But that's where we'll start. We'll be honest with the employers, the public, the government about the problems and the solutions. We will work on projects in our area of expertise. We will work, not just talk. We'll work. And that work will be eliminating fossil fuel use, greenhouse gas emissions, and the project requirement will be a requirement of our work, like safety and reliability. So the rest of this group are actually professional engineers. And they actually see this as something like a movement like safety engineering was, where you change the ethos of how the job is done to include the things that society's counting on you to include. And we will do the work of changing existing systems. The future is about how this system changed, not about the miracle green technologies that were added onto it, put on its roof. It's about how this system changed. All right. And that change is about a step down in demand of energy and materials. Thank you.